All right, today we're looking at number 2, number 3, and number 5. And the first thing that I want to point out, this is kind of the first basic thing about number 2, is that if you see this phrasing of do the data provide convincing statistical evidence, then that should be a clue to you that we are doing a hypothesis test. A 4-step, give your null and alternative, get a p-value, interpret it. Do not try to answer this in general and reading off the table. You're actually going to be doing it on part B. But it is asking for a hypothesis test. And more specifically, this one is asking for you to do a chi-square test. So let's take a look at that. They did this as a chi-square test of homogeneity, although they did accept the answer of chi-square test of association. Two big things here. First off, and this comes up in number 5 as well. First off, you need to state the test that you are using, or the name of the interval that you are using. They are going to look for that every time. So you either need to say chi-square test of homogeneity, again, they also took association, all right, or you need to have this formula here without the numbers plugged in. So formula with the numbers plugged in is good too, but you also you need to have one of these two things in order to get the points for stating the name of the test, because the formula implies the name of the test. Formula with the numbers plugged in does not. So same thing when we get down to number 5, going all the way down to number 5, when it asks for that confidence interval, specifically, it's going to want you to say either that we are doing a 1 proportion z interval, or give this formula. Otherwise, you're not going to get credit for stating the name of the test. Usually I have you do both. Do this, name the interval in step 2, and give the general formula in step 3. But a lot of people forgot to do that, so make sure when you're doing confidence intervals and hypothesis tests, you're saying what kind of test or confidence interval you are building. All right, back up to number 2. The other thing that people missed on part A was the conditions. So remember that normal is not a condition for chi-square tests because chi-square distribution is not a normal distribution. The actual condition you need to check is that the expected counts are at least 5. The expected counts being at least 5. And in this case, here's where the expected counts were, and they're at least 5. And you need to say what the expected counts are in order to get credit. Don't just say that all the counts are at least 5. Show what the counts are and show that they're at least 5. Right? You do that when you check n times p and n times 1 minus p and say that they're both at least 10. You don't just say they're both at least 10. You show doing n times p. You show doing n times 1 minus p, and you show that they're, and you say after that that they're at least 10. There's your chi-square statistic. It also wanted degrees of freedom at some point. So make sure you say degrees of freedom, which is your row total minus 1 times column total minus 1. And then there's your p-value that's less than the 0.05. That means we're rejecting the null hypothesis. There is enough evidence that the proportions differ based on the add choice. Or, if you did it as association, that there is an association between snack choice and the add that gets viewed. Part B, to get full credit for Part B, a lot of people got partial credit. To get full credit, you needed to cite specific proportions. So you needed to say not just that this ad had an effect, but saying specifically how much of an effect got used, and comparing proportions and counts and all that stuff off of the table. That's specifically what they wanted you to do. So to give a very brief overview of how they scored this, you had to give the null and alternative hypothesis correctly. You had to say it was a chi-square test of some kind. You needed to check the expected counts were at least 5 and say that. You also needed the correct statistic, correct degrees of freedom, correct p-value. Then this is your step 4 sentence written correctly. And type A had little, ad type A had little effect and ad type B had an effect, both supported by observed proportions or counts from the table. So that was the part that a lot of people missed. All right, number 3. You can pause and read the overview of exactly what they were looking for, but I want to point out a couple of things as I scroll down to the scoring so that you can know specifically what they were looking for. Essentially correct if both variables are described correctly. A correct description includes some degree of status of the variables. That's the thing that people missed. For example, a lot of people put that the response variable was the risk of Alzheimer's. And if you're saying the risk of Alzheimer's, then that's not a variable. That's not something that I can describe an effect of or a count of. And so you need to say specifically, how are you measuring risk in order to get credit? And the way that you would probably define it is whether you develop Alzheimer's or not. That would be your degree of status. Now I have a thing that I know what question I am asking the people. And it gives that note here. Describing the variables only as smoking and Alzheimer's without a reference to level/status is not sufficient. So most of you got partially correct there and not essentially correct. Part B. Correct type of study, observational, and provides a correct description that smoking status was not assigned or that smoking status was only observed. So you need to specifically do that in the context of the problem. If you said it was an observational study because there wasn't a treatment, then that would be partially correct because you didn't specifically apply the definition of observational study to the context of that question. And then part C, you should be saying that exercise may affect smoking status. The idea of a confounding variable is that the effects of the confounding variable and the explanatory variable can't be distinguished in how they respond. So that it's hard to tell the difference between whether the smoking or the exercise caused the risk in Alzheimer's. And so you need to say both that exercise and smoking may have something to do with each other, and that exercise and Alzheimer's may have something to do with each other. And you need to describe how that happens. That's how you describe the confounding variable. And again, in the comments of the assignment, I tried to give specific feedback to you on what else you needed to say on each of these parts. Down to question 5. Confidence interval. And that's a 1 proportion Z interval. Some of you may have been very happy to see that it said that the conditions have been met. Assume the conditions have been met. So you did not need to do that. You needed to say the type of interval you were doing and then do the calculation and interpret it. Most of you did a good job with that. Now, Part B was tough to get the point for. In Part B, you didn't just need to say that it's the normal condition, right? Good if you identified that it was the normal condition, but they also wanted you to kind of explain why that is the normal condition. Why is that the condition that we are checking to use the normal distribution? So the formula for a confidence interval relies on the fact that when we go to the sampling distribution, we can use a normal approximation of the actual distribution, which is a binomial distribution. So that's the reason we're using a normal distribution. And they looked for you specifically to say that in order to get full credit here. So this was tough to get all the points for. Part C was a little bit easier. Part C, they were just asking for you to identify. They said, well, we have two proportions there, so why can't we use a two proportion Z interval instead, or two proportion Z test? Well, we can't use a two sample Z interval for proportions because there was only one sample there. So we can't use a two sample interval for something where there was only one sample. Another way you could say that is that these two proportions are not independent of each other. Because they are coming from the same sample, if more people choose one of the kinds of statements, fewer people have to choose the other kind of statement by necessity of the way that that's carried out. So again, the way that the scoring is broken down, you needed to state one proportion Z interval or give the formula, and then calculate out the confidence interval correctly. Then the next part is about your interpretation of the confidence interval, making sure you wrote the sentence correctly. Most of you did a good job on that. And then to get full credit, you had to get both parts B and C correct. So I'd say some of you earned partial credit because you got part C. That's where most of you fell. All right, we will go through the rest at a later time. And if you have any questions on this, feel free to come see me and let me know. But that is all for now.